share. Can you guys see my screen?
Yes.
Yes.
Okay. So this is our first community meeting. It's going to be pretty quick. We're just going to go through just, our latest 0.1 release, and then the next release discuss some new features. And then we had some feedback from the Rook community yesterday. I could share that. And then we also have some PRs that Matt will go through. So let's just get started. The first item, we had a 0.1 release a couple weeks ago. I believe, Matt, that was the one we have a demo for, right? With the Engine X pods?
Yes.
Yeah. So that one is just, we're able to do resource prediction for CPU and memory, and then expose it as CRD objects onto the cluster, right?
Yes. And we have a matrix prediction and some recommendations. And the recommendations is just based on doing some VPA stuff, VPA activation.
Yeah.
Yeah.
Just mainly VPA, and we don't have the others, the HPA and CPA thing, right?
Yeah, not yet. But compared to the native VPA, our advantage is we look into the future metrics.
Yeah, exactly. Yeah, everybody else just does current usage, whereas we can use AI to learn the behavior and then predict the future.
Yeah.
Okay, good. And then the next release, what is that's 0.2?
Yeah.
Okay, and is this going to be basically the next release? This the one we proposed to Rook?
The one we proposed to Rook, it has one extra feature, that is the disk failure prediction. Okay, so without the disk failure prediction, that's basically our 0.2 release.
Okay, so okay, yeah. So our disk failure prediction is not done yet. We're just for Rook for 0.2. We're just going to have. Well, I don't know. What is the diff?
Yeah.
We'll do HPA.
No. With the disk failure prediction, we just have some algorithm in the Alameda AI, and we also need one more disk log exporter. So that's the data, the smart data coming from. So with these two extra modification, then we can have the failure prediction.
Or yeah, I know. But then for 0.2, what's the difference between 0.2 and 0.1?
Oh yeah, there's four items we have some changes. One is we have some better architecture design, that is we componentize those architecture. So you can see in 0.1 we just only have the component operator and the Alameda AI, and in 0.2 we move the data access part function from operator to data hub component. As for the that should be good to the scalability if we have a huge data access. And we also add one more component called Crane. That's for the automation part from the recommendations.
Crane, yeah. So this is going to be optional, I guess, for a lot of people, because if they want to do it themselves, they won't need.
Yeah. This one can be optional.
Okay, that makes sense.
And we also have a dashboard here. That's also optional, and then the dashboard can be visualized the predicted metrics.
Okay, so yeah, we just made our architecture more componentized, and then we Yeah, so it's easier integration. That's also because Marcel from Red Hat suggested that, for those that don't know. Yeah.
Yes.
Okay, great. That's good. So as you guys saw, we had that, we proposed this design to Rook, and they had a couple things to feedback to us. I posted in the Slack, but I can go through it again. It's the first one was that they wanted us to still offer out disk failure prediction as CRDs. They don't want to use our data hub because they want to keep our operators separate for now. I think they want it to be decoupled. So,
In my thoughts, the disk failure prediction is some kind of recommendation that we recommend them to replace the disk, right? So it's kind of recommendation. So we plan to put that information into the recommendation CRD.
Okay. No, but I thought we weren't going to use CRD recommendations anymore. I guess we're still going to use that.
We will still have that. So you can see the CRD here in the middle of
this one.
Yeah, this one, yeah. So this one only exposes the recommendations.
Okay, but not the raw prediction. The raw prediction all goes in Data Hub.
Right? Yeah, and go into the InfluxDB.
InfluxDB. Yeah, because I was a little confused. I saw somewhere that you said that we weren't going to use the CRDs anymore, but I guess that we're just going to use CRDs for recommendations only.
Yeah, and I think that's Rook Rook's one, right?
Yeah, well, they're mainly interested in the disk failure prediction. So
yeah, so we put that into that study.
Okay, yeah, good, great. That's good news. And then second one was, I think we were thinking of using their config map to like update the disk failure predictions, but they recommended not to use the config map because in the future they could like change the architecture or the layout of it, and then we would have to like version it and then keep track of the different like layouts in order to maintain compatibility, you know.
Yeah, so we will not change that. We just stay in the recommendation here, and Rook will start from there, right?
Yeah, sounds good. And then yeah, I think that's it. The rest was mostly they didn't really look too much into it yet, so we have to give them some time to study it, and then we can discuss further in the next meeting.
Yeah, and for the information collection part, I will create another PR in our repo, and to address what correlation information we need, and what part of the information that should be from Rook.
Yeah, see, that's hard because I tried to ask them what they were going to do with the prediction in their meeting. They didn't even know. They're still pretty like raw on this idea of prediction. So
yeah,
it's kind of hard to see like what information we need if we don't even know what they're going to do with it. So
yeah. As for the correlation, I think we should let educate them that what we can do with those correlation. Like if we have some disk that's going to failure, and maybe some pools is using one of the failed disk, then all those rest of application or any application using the same pool will be impacted, right? And maybe for some performance prediction, then we can also predict that what if some disk is failure, that should be some performance degrade.
yeah, if we can give some examples to them to like give them a better idea of what they can do, that'd be good. I know we already have Ceph examples, but maybe like if we can find something that like they also have Minio and Cockroach and stuff, maybe if we can find some other stuff they can do, that'd be good. Yeah, I'll look into that.
Yeah, I will start from a PR, and we can start to approach and with that PR.
Okay, great. Yeah, I'll wait for your PR then.
Okay.
Okay. Yeah, that's all the feedback from Rook. Did you want to go over a PR? I see you posted 150 over here.
Oh, yes.
Okay, let me.
Alameda.
Or do you want to share the screen, or do you want me to? Is this okay?
Use your screen. Okay. Yeah.
Okay.
Can you just go to the file to see the empty file? Yeah. Yeah. I will just quick go through those some figures here.
Okay.
Yeah, and this figure is not. This is not new. It's just illustrate that our advantage is to recommend. Our recommendation is basically is global planning, so it's not just doing VPA or just doing HPA or just combine those independent scalar into one. We are looking for more globally planning, so that should be more effective in the resource use usage, right?
Yeah, we do all the VPA, HPA, cluster scaling, and scheduling all in one package rather than like having everything be like its own solution. It's pretty good.
Yeah, and the user just need to specify what paths need prediction and recommendation, and also provide some policy, and then Alameda will act accordingly.
Yeah, the user selects the user picks which pods need the scaling and prediction, and then we'll look for it, right? Our operator finds it based on the objects they create.
Yeah. And right now the policy is there's two policy provided, one is stable and one is cost saving.
Oh yeah. I remember I talked to you about it. Maybe you can like give a brief description of what each is. Stable and cost saving.
Stable, we think the cluster is more stable if their restarting times is less. Yeah, and if and cost saving means that if we can put more paths into one node, then we can need less nodes. Less nodes means more cost saving.
Yes, I'm still a little. I was still a little confused on stable. So stable, is it like our like before where it was it would try to like balance the load on each node, like by putting pods on like the least used node. Is that what stable is?
I basically try to put paths on those nodes that it can be much more less frequently evicted, because if you
Oh, I see. I got it. Yeah. So like the least chance of being moved out of the pod, like so it will stay in the same pod for most likely to stay in that pod for longer. I get it. Yeah. Okay.
Okay, go to next figure.
Next figure.
Yeah, and this is also not new. Let's just illustrate that we are why we are going to be in the Kubernetes ecosystem. We are not to replace anyone. We are trying to be part of it and provide some intelligence for those resource orchestrators, so we can work together.
Yeah, that's good. So people don't think we're competing with them. We can work together with them. Yeah.
Yeah. So right now there's six functions that we will provide in Alameda. Yeah. So you can see
CPU, memory.
No, it's an API and hardware analysis, right?
Oh,
yeah, that's the last function we are going to provide.
API hardware. Okay. Oh yeah, these are just these are our components put into like architecture. Okay. Cool.
Okay. So please next figure. Yeah, this is the whole architecture for Alameda in 0.2. So you can see those yellow part is implemented in Alameda. So we create two CRD, which is the Alameda scalar and the Alameda recommendations. And the Alameda scalar is for user to specify which parts we are that they need the recommendations. And after some computation, Alameda will show the user that the recommendation in the recommendation CRD. And if user like if the user like we just automate it, then he can enable this current component. Then we will just do what the recommendation says.
Yeah, so this is basically what we showed Rook without the, like you said, without the disk failure prediction.
Yes.
Yeah. I have a question about this connection. Shouldn't it be the arrow be the other way around? Data hub into InfluxDB?
Yes, actually it should be two direction.
Two direct. Or what does the data hub grab from InfluxDB?
For Alameda AI, if you want to do some recommendation, you will look into the predicted measures, right? So you will go back to InfluxDB to see what. Yeah.
I see. Yeah, to get the old predictions, or yeah. Okay.
The fresh prediction.
Yeah. The feature.
That will refine this figure. Yeah.
Okay. Great.
Okay.
Is there any other?
No. Yeah.
Oh, it's a GIF. Yeah.
Yeah. This one just no. Yeah. Here. Please stay here for a while.
Okay.
Yeah, this one just animated. Actually, there's three stages in this animated figure. So actually Alameda can work with just the core function. That is just the operator component, Alameda AI, and the data hub. The crane is optional, and the Grafana is optional. If the user don't want the dashboard, if they don't want to execute it, then you can just install these three components.
Okay. Yeah, that's a lot more clear now, because before we had everything together, but now we have a core and then we have optional. Okay.
Yeah, this one Marcel wants, I think.
Yeah, I think we'll connect with Marcel next week, see if he's able to install it.
Yeah, and one more thing I want to add is you can see Alameda AI and the data hub is there could be some replicas here, right? That depends on how heavy the loading is. So if there's a very high loading to access the data, then we can just the replica set can change its replica, then the data hub will duplicate more paths to serve more requests. And so does the Alameda AI.
So yeah, I remember one of these questions came up in another Rook meeting. It was they were wondering how much load does this Alameda AI actually have on the cluster? Because maybe we can think about like moving it outside of the cluster.
That can be done, and I think in our commercial version, that should be we can host a cloud services to provide the Alameda AI component feature.
Yeah, because that sounds good, because we actually don't know. This might take a lot of load on the cluster that people might not have.
So if you want to move the AI computation to another cluster, you can just move the Alameda AI to that cluster and communicate with the target cluster with the data hub.
Okay, great. Sounds good. Yeah. Okay. Did you want to go through this?
And last figure is this message sequence chart that it's just illustrate the normally Alameda workflow. So it starts from user to create the Alameda scalar CRD, and that tells Alameda which path needs prediction and recommendations.
Okay.
Yeah. And we will store that information into InfluxDB. And later, when Alameda AI is triggered, we will look for the list in the InfluxDB and start the model training, and with the model, train the model, then you will start to do the prediction. So this flow is just illustrate the prediction part, and the model training is another. There's another independent thread that doing that model training part. Yeah.
Okay. Model.
Yes. So you can see in the when Alameda is generating predictions and the recommendations, it starts to retrieve the historical metrics, then generate the predicted metrics, right? And then with those predicted metrics, it can start to compute the recommendations.
I see.
Okay, and this one I need to refine this. Yeah, this arrow needs to write the recommendation. I'm sorry. Actually, okay. Let me go back to okay. It start to retrieve the historical metrics. Then the metrics is used to accompany with the trained model. Then it start to generate the prediction and the recommendation. And the prediction is going to InfluxDB, and the recommendation is going to the CRD.
Recommended. Okay.
Yeah.
Oh, I see over here. Yeah. That makes sense. So it's just an illustration of how the pod goes to our AI engine, and then how we predict, and then we send back a recommendation. Got it.
Yeah. And then they store in two different places.
Yeah. And I guess this answers the question I had earlier. What does our InfluxDB go to our data hub?
Yes.
The list. Okay. Great. Yeah. This is very good design doc. Thanks.
No problem.
Yeah, I'll definitely study it a lot more. Maybe I might have a lot more questions for you later, but it looks really good.
Yeah.
Okay. And I think that's it for our meeting. Does anybody in the chat have any questions or comments?
I'm good.
You're good, Brian?
No question.
Or Jeremy, I see that you're here. Do you want to say anything about Alameda?
I have a few questions, and for you, Brian, and Matt, but we can discuss it offline.
Okay, we'll discuss it offline then. Okay, then that concludes our meeting. Thank you guys for joining. We'll have the next month, the third Wednesday, we'll have another community meeting. I'll send another reminder to everybody. Thank you guys.
Yeah, thank you.
All right. Bye.
Bye.